Good morning. Today our new class is full wave bridge rectifier and advantages and disadvantages of bridge rectifier. These two topics are discussing one by one now. Okay. Next, recap of this presentation. In previous class, we discussed about types of full wave rectifiers, center tapped full wave rectifiers, advantages and disadvantages of center tapped full wave rectifiers. These three topics are completed in previous class. Next, objectives of this presentation. On completion of this period, you would be able to understand first of all full wave bridge rectifier. This is another type of full wave rectifier. Actually, full wave rectifiers are two types. Basically, full wave rectifiers are two types: full wave center tapped rectifier, full wave bridge rectifier. Already full wave center tapped rectifier advantages, disadvantages completed in previous class. Now, full wave bridge rectifier. On completion of this period, you would be able to understand full wave bridge rectifier and advantages and disadvantages of full wave bridge rectifier and summary. Okay. So these topics one by one discussing now. Okay. So first topic is full wave bridge rectifier. Full wave bridge rectifier. Okay. So full wave operation can be obtained even without the center tap transformer in bridge rectifier. The full wave operation can be obtained even without the center tap transformer in bridge rectifier. Okay. So this bridge rectifier contains 4 diodes D1, D2, D3, D4 connected to form a bridge. So in this rectifier, so it consists of 4 diodes, 1 transformer, 1 resistor. Okay. 4 diodes are D1, D2, D3, D4. These diodes are connected to form bridge shape. Okay. So this is the circuit diagram of full wave bridge rectifier. And these are input and output waveforms of full wave bridge rectifier. So these waveforms are similar to center tapped full wave rectifier also. Okay, but operation is different. Okay. Next, so in this circuit diagram, observe this. You can take any one circuit diagram. Here 2 circuit diagrams are displayed, but you can select any one of the circuit diagram. Both are same. Okay. So observe the circuit diagram. So transformer, primary winding. So the input signal, alternating input signal voltage, that is AC supply voltage. We can find out input waveform AC signal waveform, sine wave. Okay. So here AC signal, input signal 230 volt 50 Hz of AC signal is applied to primary winding of transformer. So this signal goes to secondary winding by using mutual induction. Mutual induction means these two parallel lines. Okay. So now AC signal, AC input, alternating voltage is present at the secondary winding of transformer AB terminals. Okay. Between AB terminals. Okay. Next. So the alternating voltage, this is the alternating voltage. So this is applied to diagonally opposite ends of the bridge through the transformer. So this AC signal voltage of secondary winding AB terminals is applied to the diagonally opposite ends of the bridge through the transformer. So between other ends of bridge, the load resistance RL is connected. Okay. So this is the bridge shape. So in this shape, alternating voltage is applied to the diagonally opposite ends of the bridge through the transformer, and also other ends, between other ends of the bridge, the load resistance RL is connected. Load resistance RL is connected. That means, so D1, D2, D1, D3, sorry, D1, D3 are connected to alternating voltage, and D2, D4, D2, D4, end of D2, end of D4, both are connected to load resistor. So D1, D3 end is connected to alternating voltage. Okay, so observe this. First of all, observe this. So during positive half cycle, the AC voltage across secondary winding AB terminals, AB changes polarities after every half cycle. So the AC voltage across the secondary winding AB terminals, this terminal polarities are changes after every half cycle. After every half cycle. Observe this figure during positive half cycle. During positive half cycle of secondary voltage. During positive half cycle of secondary voltage. So first of all, observe this input and output waveforms. Here input is the first waveform is the input waveform, input signal. So that is applied to the transformer. So that goes to secondary winding. Here, so the complete full cycle not taking at a time. So half of portion, positive half cycle is taken one time and another negative half cycle is taken other time. Okay, first of all, so we can apply positive half cycle. During positive half cycle of secondary voltage. During positive half cycle of secondary voltage, the end A of secondary voltage, secondary winding becomes positive and B is negative. During positive half cycle, end A is positive and B is negative. So we can apply end A and B. And A is positive, that is connected to anode of diode D1. Anode of diode D1. So that means end A is positive. So positive is connected to positive. So D1 is forward bias. Diode D1 is forward bias. Okay. So D1 is forward bias and D2 is reverse bias. Next, B is negative. So negative is connected to cathode. Cathode means negative. Negative is connected to cathode of diode D3. So negative is connected to negative. That's why it is also a forward bias. So here D1 and D3 both are in forward bias. So D1, D3 act as a closed switch. D1, D3 act as a closed switch. They conduct current also. This makes diode D1, D3 are forward biased while D2, D4 are reverse biased. Therefore, only diodes D1 and D3 conducts current. So these two diodes will be in series through the load resistor. These two diodes will be in series through the load resistor. I repeat once again the operation. During positive half cycle of secondary voltage, end A becomes positive and B becomes negative. And A becomes positive and B becomes negative. This makes diode D1 and D3 are forward biased and diodes D4 and D2 and D4 are reverse biased. Therefore, only the diodes D1 and D3 are conducts currents. So otherwise D2 and D4 does not conduct because both are in open switch. There is no current flows through the circuit of D2 and D4. Okay. So then D1 and D3 are forward bias. That's why it acts as a closed switch. Then the current flows through D1 and D2 in series direction through the load resistor. Okay. So therefore the current flows through the load resistor RL. The output appears across load resistor. Okay. This operation is understand. Next, during negative half cycle of secondary winding. The voltage, the end A becomes negative and B becomes positive. Observe this, NDA becomes negative and NDB becomes positive. This makes, so A is negative. Negative is connected to D4. Negative is connected to negative. Cathode of D4. So negative is connected to anode of D1. Negative is connected to anode of D1. So negative is connected to positive. That's why D1 is reverse bias. What about D4? Negative is connected to cathode of D4. Cathode means it is negative. So negative is connected to negative. This is same polarity. That's why D4 is in forward bias. So next, and B becomes positive. So positive is connected to anode of D2. Positive is connected to anode of D2. Anode means it is also positive. So positive is connected to positive. So that's why D2 is forward bias. What about D3? Positive is connected to cathode of D3. That's why positive is connected to negative. That's why it is reverse bias. Here this makes that only the diodes D2 and D4 are forward bias. Only the diodes D2 and D4 are forward bias, while D1 and D3 are reverse bias. While D1 and D3 are reverse bias. Therefore, only the diodes D2, D4 act as a closed switch and conducts current. So these two diodes will be in series through the load resistor. These two diodes will be in series through the load resistor. The current flows through load resistor, that is in the same direction. The current flows through the load resistor, that is in the same direction as for the positive half cycle. Therefore, DC output is obtained across load resistor RL. I repeat this point also. Therefore, the diodes D2 and D4 are conducts currents. So, because these two are in act as a closed switch, remaining D1, D3 act as a open switch. That's why there is no current flows through D1 and D3 diodes. Here, the two diodes conducts currents. These two diodes will be in series through the load resistor RL. The current flows through the load resistor RL, that is in the same direction as for the positive half cycle. Therefore, DC output is obtained across load resistor. Therefore, DC output is obtained across load resistor RL. Okay. So, this is the operation of full wave bridge rectifier. This is the operation of full wave bridge rectifier. Okay. Next. So, next topic, advantages of bridge rectifier over center tapped full wave rectifier. Advantages of bridge rectifier over center tapped full wave rectifier. So, the first advantage of bridge rectifier is no center tap is needed in the transformer secondary. No center tap is needed in the transformer secondary. Okay. So, the output is, second one is, the output is twice that of center tap circuit for the same secondary voltage. Here, the advantage, second advantage of bridge rectifier is the output is twice that of the center tap circuit for the same secondary voltage. Okay. And next, the third advantage of bridge rectifier over center tapped full wave rectifier is the peak inverse voltage is 1/2 that of the center tap circuit. The peak inverse voltage is 1/2 that of center tap circuit. Okay. The peak inverse voltage is 1/2 that of center tap circuit. These three are the advantages of bridge rectifier over center tapped full wave. Bridge rectifier over center tapped full wave rectifier. Okay. Next, disadvantages of bridge rectifier over center tapped full wave rectifier. The first disadvantage of bridge rectifier is it requires 4 diodes. It requires 4 diodes, but center tapped full wave rectifier requires only 2 diodes. But in case of bridge rectifier requires 4 diodes. 2 diodes are more compared to center tapped full wave rectifier. Okay. So, 2 diodes are more. That's why cost is high. That's why cost is high compared to center tapped full wave rectifier. And third disadvantage of bridge rectifier over center tapped full wave rectifier is, as during each half cycle of AC input, two diodes that conducts in series, therefore voltage drop in the internal resistance of the rectifying input will be twice. I repeat this point also again. As during each half cycle of AC input, each half cycle means positive half cycle, either negative half cycle. Each half cycle of AC input, two diodes that conducts are in series. Therefore, voltage drop in the internal resistance of the rectifying unit, that means internal resistance of the diodes will be twice. Okay, so these three are the disadvantages of bridge rectifier over center tapped full wave rectifiers. Bridge rectifier over center tapped full wave rectifiers. Okay, so advantages and disadvantages of bridge rectifier over center tapped full wave rectifier is completed. Next, summary of this presentation. We have seen full wave bridge rectifier and advantages and disadvantages of full wave bridge rectifier. Advantages and disadvantages of full wave bridge rectifier. And next, frequently asked questions may be asked. The first question is, explain the operation of bridge rectifier. Explain the operation of bridge rectifier circuit with waveforms. Explain the operation of bridge rectifier circuit with waveforms. Okay, so in this topic, so different way of questions may be asked. Draw the circuit diagram and input and output waveforms of bridge rectifier. Draw the circuit diagram and input and output waveforms of bridge rectifier. Okay, and next, second question may also be asked in, write the advantages and disadvantages of bridge rectifier. This question may also be asked, write any two advantages and disadvantages of bridge rectifier, or write any three advantages and disadvantages of bridge rectifier. Different types of questions may be asked, depends on marks. Okay, so this question may also be asked, write advantages of bridge rectifier, or may also be asked in this question, write any three disadvantages of bridge rectifier. This question may be asked in combined advantages and disadvantages, or may be separate. Only advantages may be asked only in disadvantages of bridge rectifier. So different types of questions may be asked. Okay, so that's why prepare well. Okay, this operation is very important operation. This operation is very important operation. See and observe. You can draw this circuit also D2, D4. Here also D1, D3. So in short circuit also. So here appears in diode, but this circuit may be drawn in short circuit also. So which diodes are in forward bias? They connect short circuit. Which diodes are in reverse bias? They connect open circuit. Okay, so you can choose any design. You can choose any circuit design. Okay, so you can apply appears in diode, or in appears in short circuit, or in open circuit. Any one you can select. You can choose. You can choose. Okay. Okay, any doubts? Okay. Thank you.